continuing, we have the expression 3x minus 7 quantity squared. Now we can see, if we think about it, that that fits the form of one of our special products, but we're not going to use that right now. And of course this form of the special product is not the best one to use because of notational things that we'll talk about down here. In any case, we're going to do this by simply using the distributive law. 3x minus 7 squared is 3x minus 7 times 3x minus 7. 3x times 3x, 3x times negative 7, negative 7 times 3x, negative 7 times negative 7 gives us, simplifying, 9x squared minus 21x minus 21x plus 49. Combining these two, again, remember, combining like terms consists of factoring out the like expression, the common factor, and adding up everything else. It gives us 9x squared minus 42x plus 49, and that's very straightforward. Okay, now, I started to use the form x plus a squared equals x squared plus 2x plus 2ax plus a squared. I didn't even write it down right. Sneak that a in there so nobody can accuse me of missing it forever. Okay, I didn't use that because this has a 3x in it, and replacing x by 3x seems a little clumsy, probably is a little confusing. So I chose rather, let's move this board over just a little. I think I'm missing a little stuff. Okay, I chose rather to use the form a plus b quantity squared because a and b don't have any common letters or numbers with 3x minus 7. So same thing as I have with the x plus a squared, but in the form a plus b squared. It's going to work a little better. Now people had a little bit of a problem with this. Okay, when I got to saying, okay, what do we have to let a equal and what do we have to let b equal in order for a plus b to have the form 3x minus 7? And so we want to make sure we understand this. Okay, now if a is 3x, then when we substitute 3x for a, we get 3x in this expression. And if b is negative 7, then when we substitute negative 7 for b, we get a negative 7, and this expression becomes 3x minus 7. So in order to apply the special product, the first thing we have to do is identify what our two letters in the special product formula mean. That would have been much more confusing had I had the x in there, if I'd have used this form. In this form, with a and b, though, it becomes much simpler to see that we're going to let a be 3x, we're going to let b equal negative 7. So that 3x minus 7 quantity squared is going to be a plus b squared, where we understand that we've made this substitution. And a plus b squared, of course, is a squared plus 2ab plus b squared. That's something we simply, of course, need to know. And then we substitute the 3x for the a and the negative 7 for the b. So a squared becomes quantity 3x squared. 2ab becomes 2 times 3x for the a and negative 7 for the b. So it's 2 times 3x times negative 7. And then b squared is the square of negative 7. Simplifying this, 3x quantity squared gives us 9x squared. Multiplying 2 by 3 by negative 7, we get negative 42. And of course we have the x, and we get the 49. Now let's do another one. Okay, and let's just be sure we understand that this and this are identical. It doesn't really matter which way we do it, but it's much more efficient and is going to be immensely helpful when we get to factoring if we know this special formula and learn to recognize expressions of this form. And with a little practice, we find that we can do that. Okay, now let's do 2x minus 3y quantity squared. Using the distributive law, we write it out, multiply 2x by 2x to get 4x squared, and notice that I'm kind of skipping a step where I write both factors of each term. And we're going to do that, but remember that we're skipping a step. That this is why this occurs. Okay, so anyhow, 2x times 2x is 4x squared. 2x times negative 3y is negative 6xy. Negative 3y times 2x is negative 6xy. Negative 3y times negative 3y is 9y squared. And then we collect our terms. Negative 6xy, negative 6xy gives us negative 12xy. So we have 4x squared minus 12xy plus 9y squared. Applying special formula again, using the a plus b letters, a and b letters, a plus b squared, a squared plus 2ab plus b squared. We're going to let a be 2x so that when we substitute, we're going to get 2x here. We're going to let b equal negative 3y, so when we substitute for b, we get the negative 3y, so that a plus b becomes 2x minus 3y. Having declared that, we can say that 2x minus 3y quantity squared is a plus b quantity squared, which is a squared plus 2ab plus b squared, with which we're getting familiar. So that is equal to, well, a squared is going to be quantity 2x squared. The a here is going to be a 2x. The b here is going to be negative 3y, so we have 2 times 2x times negative 3y for the 2ab term. And then b squared is the square of negative 3y. Okay, doing the arithmetic on that, we end up with 4x squared minus 12xy plus 9y squared, which agrees with what we got when we used the distributive law.